Welcome to homework.
Alrighty, so for this problem, we want to show that a positive integer is divisible by 3 only if the sum of its digits is divisible by 3. And we're going to be using corollary 2. So I went ahead and wrote it out here. But these are going to be little tricks we use to get to the end of this problem. And so we'll just start with the fact that if we let b be any integer, it's going to be an integer that's greater than 1, then we can write out any integer uniquely in the form a k b to the power of k plus a k minus 1 times b to the k minus 1, right, all the way down to a1 times b to the power of 1 plus a naught and b to the power of 0. And sometimes, of course, this 1 is left off in this last one, since b, anything to the power of 0 is equal to 1, is also left off. Okay, well, in this case, we have base 10, so we want to replace b with 10. So that would just give us a k to the 10 to the power of k. Right, we'd follow that all the way along to a1 times 10 plus a naught. So going forward, I'm just going to leave those off. Okay, well, we know, right, 10 mod 3 is equal to 1. And so we're going to exploit that. Okay, so if we take n mod 3, then we can use this expression, mod 3, right? So any integer n, we'll just use this version of it. All right, then using our corollary, we can split that up. So since we have this summation in here, this is going to be equal to, say, a k 10 to the k mod 3 plus a k minus 1 to b to the power of k minus 1 mod 3 plus all the way down to a1. I almost wrote a b there, but of course we're working with 10, so a1 10 mod 3 plus a naught mod 3. Then this whole thing, we also will take mod 3. Okay, well, now we have these products inside, right? So using all these products, we'll use the second part of our corollary and split those up. So then we get AK mod 3 times 10 to the power of k mod 3 I'm going to take that mod 3. We'll do this down to every expression that's in there. Down to our last one. So, of course, perhaps a not very elucidating, so we'll use a1 mod 3 times 10 mod 3. You would take that. It's going to put m3, but mod 3, right? And then plus a not mod 3. Then this whole thing, we still have mod 3. Okay, well, 10 mod 3 is equal to 1, right? So this is equal to 1, that's equal to 1. So we can simplify quite a bit, and it's going to end up being equal to we'll get AK mod 3 plus AK minus 1 mod 3 plus A1 mod 3 mod 3 plus A naught mod 3 mod 3. All right, so we're going to simplify a little bit more here. Or more speaking, we're just kind of combining our terms, right? So we have everything separated, but we're going to reverse it and sort of stitch it back into our previous form. So we'll get AK mod 3 plus AK minus 1 mod 3 plus A1 mod 3 plus A naught mod 3. And this whole thing is going to be mod 3. Okay, well, we can then simplify this again. So this is going to be a k plus a k minus 1 plus all the way down till we get to a 1 plus a naught mod 3. So, and remember this was initially equal to n mod 3, right? So if n mod 3 is equal to this mod 3, then this positive integer n is only divisible by 3 when this expression here is equal to 0. Okay. Well, that only happens if the sum of the digits are divisible by 3. That's exactly what having the sum of the digits being mod 3 means. So that concludes this little proof here.